Welcome to the Surgical Theater. I'm your host, The Strategist, and today we are going to treat Cambridge IGCSE Mathematics, specifically Syllabus 0580, like a clinical, precise operation. Listen, mathematics at this level, it's absolutely not about memorizing random rules and just hoping for the best. It's about having a set of precision instruments and the steady hands to use them under pressure. Let me paint a picture for you. Picture two students taking the exact same exam. First, we have Alex. Alex overloads the working out space with raw mathematical facts, writing down every formula under the sun but with zero actual analysis. Then we have Sam. Sam rushes, completely misses the specific command word requirements, and calculates the wrong thing entirely. In this explainer, we are going to fix both of those approaches. We're going to dissect Pythagoras' theorem in trigonometry with absolute surgical accuracy so you don't make their mistakes. We'll examine the anatomy of the questions, select the exact right tools for the job, and anticipate the exact complications examiners try to throw your way.
Okay, let's really dive into this. When you open that paper, the clock is ticking, the pressure is on, and you see a complex geometry problem. How do you diagnose exactly which tool to pull from your mathematical toolkit? Well, many students, frankly, they just panic. They see a triangle, freeze up, and start guessing. If we look at Alex's paper, it's covered in red ink because there's just a brain dump of equations but no clear path. If we look at Sam's paper, it's red ink because Sam didn't decode what the question actually asked for. But a top-tier student, a true mathematical surgeon, scans the problem, identifies the crucial angles and sides, decodes the command words, and knows instantly whether to reach for Pythagoras, basic trigonometry, or the advanced sine rule. Our absolute goal today is to build that instant, split-second diagnostic ability in you. Today, we are going to equip you with a complete, foolproof toolkit for tackling any Pythagoras or trigonometry question step by step. We will start with the basic anatomy of right-angled foundations, move on to your core instruments with SOHCAHTOA, take those tools into real-world diagnostics, learn advanced surgery for non-right angles, and finally, prepare for a massive exam complication, the ambiguous case trap. We are also going to overlay the Peel framework, point, evidence, explanation, link, to show you exactly how top students structure their answers for maximum marks. Now, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's scrub in.
Section 1. Let's start with the basic anatomy, the fundamental structure of the right-angled triangle. Because before you can perform complex operations, you absolutely must understand the foundation.
Now, what's really interesting here is looking past the algebra to the actual geometry. Instead of just blindly memorizing a squared plus b squared equals c squared, like Alex does, look at this. It visually proves Pythagoras' theorem by demonstrating that if you take the area of the squares on the two shorter sides, so here, square b has an area of 4, and square c has an area of 9. They add up perfectly to the area of the largest square, A, which is 13. We can literally prove this by counting the 4 smaller triangles inside square A plus the little square right in the middle. It is a beautiful, unbreakable rule of right-angled anatomy. In our Peel framework, establishing this relationship is your evidence. It's the mathematical law you're bringing to the table.
So the absolutely crucial point here is identifying the hypotenuse first. Because the largest square naturally rests on the longest side, this side, the hypotenuse, anchors your entire diagnostic process for the rest of the problem. If you misidentify the hypotenuse, I guarantee your entire calculation will collapse and you'll end up with a page full of red marks like Sam. The trick? Always spot the right angle, look directly across from it, and lock on to that hypotenuse. It never touches the 90-degree angle. That is your starting point in the Peel method. Identify the target.
Section 2. Once you understand the basic anatomy, it is time to pick up your precision instruments. Pythagoras is fantastic for finding a missing side when you know the other two. But what if angles are involved?
This brilliantly illustrates your primary surgical toolkit, SOHCAHTOA. When you have a given angle, represented by the Greek letter theta, your triangle sides take on very specific roles. The side physically opposite your angle is simply the opposite. The side right next to it is the adjacent. SOHCAHTOA helps you remember the exact fractions, or ratios, connecting these sides. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. For any specific angle, these ratios are always mathematically constant no matter how massively big or microscopically small the triangle is drawn. Alex writes the word SOHCAHTOA at the top of the page but fails to apply it. We are going to apply it.
Let's see how this builds into a foolproof 4-step framework.
I want you to imagine a 60-second timer right now. If you're rewriting a flawed answer, this is how you turn those red pen marks into green check marks. First, always draw a clearly labeled diagram if one isn't provided. Second, label your sides, H for hypotenuse, O for opposite, A for adjacent. Third, look at what you know and what you need to find to decide on your correct ratio. If you have the adjacent and need the hypotenuse, you use cosine. Finally, write out and clinically solve the equation. This routine is your explanation phase in the PELL framework. It shows the examiner exactly how you arrived at your conclusion step by step, ensuring you never lose those easy method marks.
But beware of a massive examiner trap right here. You can follow the framework perfectly, but your entire operation will fail before it begins if your equipment is faulty. Always verify your calculator is in degree mode. If you see rad for radians or grad for gradients in the little window on your screen, change the setting immediately. Otherwise, every single calculation you make will output the wrong answer. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 3. Let's take these instruments out of the textbook and into real-world diagnostics. Examiners love to test your spatial reasoning by taking these triangles and placing them in actual physical scenarios.
Welcome to Challenge 1 of our interactive workshop, the data scan. Imagine a 60-second countdown timer on your screen right now. Scan these two images. Notice how the angle of elevation looking up at a tree pairs visually with the angle of depression looking down at a boat. Did you extract the core trend? Here is the trick that catches thousands of rushing students like Sam. Both of these angles are always measured from a flat, horizontal line. An angle of elevation looks up from the horizontal. An angle of depression looks down from the horizontal. And because of the geometry of alternate angles, those z-angles you learned about years ago, the angle of elevation from the boat up to the top of the cliff is mathematically identical to the angle of depression from the cliff down to the boat.
Now for Challenge 2. Find the flaw. The crucial point when diagnosing larger real-world spaces is knowing how your tools react to obtuse angles. Let's say a student writes, "The angle is 120 degrees, so the cosine will be a positive fraction." Boom! Red pen. That's the sentence losing marks. Up until now, we've only dealt with acute angles in right-angled triangles. But in broader geometry, you'll encounter obtuse angles, those between 90 and 180 degrees. If you type these into your calculator, you'll see the real trend. Sine stays positive, keeping the exact same value as its supplementary acute angle. But cosine unexpectedly flips to a negative value. Understanding this behavior by symmetry is absolutely vital for checking your answers in advanced problems. It's your link in the Peel's framework. Verifying your final answer makes logical sense. Section 4. So, what happens when the triangle isn't right-angled and SOHCAHTOA no longer works? This is where we step into advanced surgery.
This brilliantly illustrates the derivation of the sine rule, showing how dropping a perpendicular line allows us to perform advanced surgery on any non-right-angled triangle. Look at triangle ABC. It has no right angle, but if we drop a height line, H, straight down the middle, we suddenly create two right-angled triangles. By using simple sine ratios on both sides, we can isolate H. When we equate those two expressions, we get a beautiful, balanced equation, side A over sine A equals side C over sine C. This is the sine rule. For Challenge 3, our speed writing task, you'd have 30 seconds to write one perfect Peel paragraph explaining this. Point: find missing side in non-right triangle. Evidence: sine rule formula. Explanation: substitute knowns. Link: calculate and attach units.
Let's see how this builds our exact checklist for when you are legally authorized to deploy the sine rule in an exam scenario. You cannot just use it blindly like Alex does. You absolutely must have a known pair. That is, you must know a side length and the angle directly opposite it. If you have that pairing, plus just one other piece of information, either another side or another angle, the sine rule unlocks the rest of the triangle for you. Memorize this checklist. It will save you immense time and stop you from going down mathematical dead ends during the exam.
Section 5. Finally, we must prepare for the most dangerous complication in the exam room, the ambiguous case trap. This is exactly where examiners separate the A-star students from the rest. Okay, let's really dive into this provocative question. How can the exact same mathematical data draw two completely different shapes? And how do examiners use this to trick you? Imagine you were given two side lengths and an angle that is not nestled between them. Most students will plug these into the sine rule, get an answer, write it down, and happily move on. But they might be missing half the picture and throwing away a huge chunk of marks in the process.
Now, what's really fascinating about this visual is how an acute angle of 44.4 degrees and an obtuse angle of 135.6 degrees can both perfectly satisfy the exact same initial data. Let's say you're given a side of 7, a side of 5, and an angle of 30 degrees. If you swing that line of length 5 like a pendulum, it can actually intersect the bottom baseline in two entirely different places. This creates two different valid realities. When you run the sine rule, your calculator gives you 44.4 degrees. But remember what we learned about obtuse angles earlier. Sine values are positive for both acute and obtuse angles. The angle could just as easily be 180 minus 44.4, which is 135.6 degrees. Don't fall into the trap of only providing one answer when two are valid.
So the absolutely crucial point is to always check your lengths. This trap only triggers when you are finding an angle opposite the longest side provided in the question data. Because the largest angle in a triangle is always opposite the longest side, this is the only time an obtuse angle could physically exist without breaking the 180-degree rule of triangles. To manage your time properly, use our time management matrix. Spend 10 seconds checking the side lengths before you calculate. It dictates whether you write down one answer or two. We've reached the end of our surgical procedure. Your mathematics success blueprint boils down to 3 rules that guarantee top marks. First, command word decoding. Know what the question is actually asking. Second, Peel framework application. Structure your working out logically. Third, the time management matrix. Allocate your minutes based on the marks available. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing right now. Our team responds to every single comment. Like and share this explainer with a study partner. Ace the Exams, your Cambridge success starts here.